Hey guys, and welcome back to another lesson on fractions. My name is Miss Danielson, and today we're looking at adding and subtracting both fractions and mixed numbers. To excel at this lesson, you're going to need a good strong base in common factors and common multiples, so I'll link a lesson down in the description box for you below in case you need that. Otherwise, let's just get started. You should already know that to add or subtract fractions, we first need a common denominator. For example, 4 over 7 and 3 over 5, here we do not have a common denominator. We've got the denominator 7 and 5. In order to do this addition, we first need to find the lowest common multiple of these two denominator values, a multiple of 7, which is also a multiple of 5. Now there's a trick for this that always works, but it won't always be your lowest common denominator. You can always do the denominator of one fraction multiplied by the denominator of the other fraction. 7 times 5 will be the same thing as 5 times 7. In this case, that's 35. And that, in this case, does actually happen to be the lowest common multiple of 7 and 5. But if we're going to multiply the denominator by some value, so in this case I'm multiplying by 5, I must also multiply the numerator by 5. So that's going to be 20 over 35. And if I'm going to multiply this denominator by 7 to get 35, I must also multiply this numerator by 7. That's 21. So 4 over 7 plus 3 over 5 is equivalent to 20 over 35, because we did times 5, remember, plus 21 over 35, because we did times 7. Now we have a common denominator. We do not need to change that denominator again. That's the denominator for our answer. We don't add the denominators, we just add the numerators and put our answer on top of that common denominator we found. So we'll do the 20 plus the 21, that's 41, and we'll put that over 35. However, we're not quite done. We can't leave our answer like this. It's not simplified. This is something we call either a top-heavy or an improper or vulgar fraction, where the numerator, that's the top number, is bigger than the denominator, the bottom number. So we need to simplify our answer, turning this top-heavy fraction into a mixed number. If you're not familiar with this, please check out the video on mixed numbers and improper fractions, again linked down in the description box below. So to make this a mixed number, think about how many 35s go into 41. There is one 35 in 41. But there would be a remainder of 6, because 1 times 35 is just 35. I need 6 more to make up 41. So I'll say my mixed number is 1 whole, and the remainder 6 remains in a fraction over that same denominator, 6 over 35. So that's our mixed number. You may just want to check now that the fractional part of this mixed number cannot be simplified. 6 can divide by 1, 2, 3, and 6. And 35 cannot divide by any of those values except for 1, which would make no difference. So our fractional part of this mixed number is already simplified. We're done. Let's try another example. Whether you're adding or subtracting will always need a common denominator. So in this example, 7/8 minus 3/4. I want to get a common denominator, so a common multiple of 8 and 4. I know my 8's timetables are 8, 16, 24, and so on. I know my 4's timetables are 4, 8. 8 is in the 4's timetable. So I don't need to change this denominator at all. I'll just multiply the 4 by 2 to get 8. And if I'm multiplying the denominator by 2, I must multiply the numerator by 2 as well. So that's going to be 7/8 minus 6/8, because 3 times 2 is 6, 4 times 2 is 8. Now that we have a common denominator, that's the denominator we're going to use for our answer. Let's just add, or in this case, subtract our numerators. The denominator stays the same. So we're going to do 7 minus 6 as the numerator, and that's going to go over the denominator, which is 8. 7 minus 6, that's 1. So our answer is 1/8. Just check that your answer is fully simplified, and it is. I can't divide 1 by any common factor that I could also divide 8 by. They could only both be divided by 1, and the fraction would stay the same like that. So we're done. Let's try another example, but this time, let's have a look at an example that could actually end up being negative. 4/9 minus 7/12. Again, we need a common denominator if we want to add or subtract fractions. So think of your nines timetable, 9, 18, 27, and so on. Then think of your 12s. Then think of your 12s timetable, 12, 24, 36. 36 sounds familiar. It's in the nines timetable. 9 times 4 is 36, and 12 times 3 is 36. So I've done 9 times 4 gives me 36, and 4 times 4 gives me the 16. And then I did 12 times 3 gave me 36, and 7 times 3 gave me 21. So I now have a common denominator, and that's the denominator of our answer. Our answer will have a denominator of 36. The numerators need to be subtracted. So I'll do 16 minus 21 at the top, and 36 is my denominator at the bottom. Now 21 is bigger than 16, so our answer is going to be negative. To perform this calculation mentally, you may want to do 21 minus 16, but then remember, we already said the answer will be negative because we're taking a big number from a small number. 21 minus 16 is 5, so 16 minus 21 is negative 5. That's negative 5 over 36. We could also write that as the fraction negative 5 over 36. Because of course when we divide a negative number by a positive number, the result is negative. So it's a negative fraction. Again, check that you can simplify. 5 could only be divided by 1 and 5, and 36 can't be divided by 5, so that is simplified or done. When we start working with mixed numbers and we're adding and subtracting mixed numbers, you should hopefully have a pretty good idea from the beginning whether your answer will end up negative or not. So if you're subtracting two mixed numbers and you end up with a negative fraction for your answer when you were expecting it to be positive, you know you've done something wrong. Usually when we're working with mixed numbers, I ask students to convert to improper or top-heavy fractions first. It's not possible to multiply or divide mixed numbers without first doing this conversion. Addition and subtraction, however, can sometimes be done in the mixed numbered format, and it could save you some time. So let's have a look at some examples where it is possible to add or subtract mixed numbers without converting to top-heavy first, and when it's not possible. Starting with the first one, 5 3/5 plus 4 2/3. Now, can I add those mixed numbers together without converting to top-heavy or improper fractions? Is it possible that my answer would be negative if I add two positive mixed numbers together? No, it's not. We started with a positive mixed number. It's just getting more positive. It's getting bigger. So it's never going to end up being negative. Now looking at the whole number parts, if I add those two together, that would make 9. But more importantly, when I add the fractions together, is it possible that I would get a negative fraction? Again, no. If we're adding two positive fractions together, there's no way it's going to end up being negative. So we can go ahead and add these two mixed numbers together without converting to top-heavy or improper fractions. First, we need a common denominator, however. The lowest common multiple of 5 and 3 is 15. To get 15 as the denominator, I did 5 times 3. So I need to also multiply the numerator by 3. 3 times 3 gave me the 9. And to get 15 as the denominator for the second fraction, I did 3 times 5. So I also had to do 2 times 5. Be careful to make sure you're always multiplying both the numerator and denominator by the same value. Now that we have common denominators for our fraction parts, we can add those fractions together, and we can add our whole number parts together. So again, 5 plus 4 is 9, and 9/15 plus 10/15, since they're both over 15, we can add together. 9 plus 10 is 19, and the denominator, remember, it does not change. It's still 15. So now we've got an answer, which is a mixed number. However, we need to simplify it. We can't leave a fraction in this format where the top number is bigger than the bottom number. So how many 15s are there in 19? I can surely fit one 15 in 19, so that's one whole. But how much would be remaining? Remember, the remainder remains over 15. 15 is 4 less than the 19, so I've got 4 remaining. So my answer would be 9 and 1 and 4/15. So that makes it 10 and 4/15. So that was the easy way of adding two mixed numbers. On to question B, however, we're subtracting two mixed numbers. Is it possible that this answer is negative? You should have a pretty good idea by looking at it. This is 7 and 2/9 minus 3 and 2/3. Regardless of the fraction part, 7 and a bit, take away 3 and a bit, will never be negative. However, if I work this out the same way I did the previous one, so I start by getting a common denominator, the lowest common multiple of 9 and 3 is 9 itself. I don't need to change this first fraction. I just need to multiply the denominator here by 3 to make 9. So I multiply the numerator also by 3, which gives me 6. So I've got 7 and 2/9 minus 3 and 6/9. Now if I try to do the subtraction the same way I had done my addition in part A, you'd see it 7 minus 3 gives me 4, positive 4. But 2/9 take away 6/9 gives me negative 4/9. Now that's going to make my working quite difficult. So if you know the answer is meant to be positive, but as you're doing the subtraction, you end up with a negative, you need to start by making your mixed numbers top heavy. Make sure you write this warning down. We do not want to subtract a larger fraction from a smaller one. This is where we need to convert our mixed numbers to improper fractions before we do the subtraction. Remember how we do that? If you don't, have a look down in the description box for our lesson on mixed numbers and improper fractions. I know that 7 wholes is 7 times 9, that's 63/9. So 63/9 plus the 2/9 is going to be 65/9. And 3 wholes would be 3 times 9, that's 27/9. Plus the 6, that's going to be 33/9. So I've got 65/9 minus 33/9. And now, as I predicted above, this is not going to give me a negative answer. I've got a common denominator. The first fraction's numerator is bigger than the second fraction's numerator. So I'll just do 65 minus 33 and put my answer over 9. So that's 32/9, which again is top heavy. 32 is bigger than 9. So we need to convert to a mixed number again. How many 9s are there in 32? 3 9s would make 27. So how much would be remaining? 27 is 5 less than 32. So my answer is 3 wholes and 5 remaining over the 9. 3 and 5/9. Again, just double check your fraction part to make sure it can't be simplified. 5 can only divide by 1 and 5, and 9 can't divide by 5. So we've got our simplified answer, 3 and 5/9. On to question C. I know what you might be thinking. I just did a subtraction and it wasn't going to work unless I converted to top heavy. But let's try this one. 4 and 2/7 minus 1 and 2/21. Hopefully you know that this answer is not going to be negative because 4 and a bit take away 1 and a bit is not going into the negatives. So let's get a common denominator here. The lowest common multiple of 7 and 21 is actually 21 itself. That's 7 times 3. So I'll do 7 times 3 on the bottom to give me 21. I'll do 2 times 3 on the top to give me 6. That's going to be 4 and 6/21 minus 1 and 2/21. Now, do I need to convert to top heavy? No, I don't, because I can do the whole number subtraction, 4 minus the 1, and I can do the fraction subtraction, 6/21 minus 2/21. As we've got a common denominator, let's just subtract the numerators. 6 minus 2 is 4. So I've got 4 minus 1 is 3, and 4/21. Again, just double check that your answer is fully simplified. It's definitely not top heavy, 4 is smaller than 21. But can I divide both top and bottom by any common factor? 4 can be divided by 1, 2, and 4, and 21 cannot divide by any of those values, except 1, which would not change the fraction anyways. So we've got a simplified mixed number answer, 3 and 4/21. Before I start talking about question D, when I'm adding mixed numbers, do I need to convert to top-heavy? Is there any way I'm going to have to deal with negative fractions in this? Not if you're adding a positive to another positive, it's just going to get more positive. So we can go ahead and add these mixed numbers as they are, simply by first getting a common denominator for the fractional parts. So the lowest common multiple of 2 and 3 happens to be 2 times 3 and 3 times 2, right? 6. So I'm doing 2 times 3, 6. I'll also need to do 1 times 3, 3. And over here I'm doing 3 times 2, which is 6. So I have to do 2 times 2, which is 4. So I've got 2 and 3 over 6 plus 5 and 4 over 6. As I'm adding, there's no worry that I'm going to end up with a negative fraction here. So let's just add the whole number parts together. 2 plus 5, 7. And let's add the fractional parts together. We've got the common denominator, so our denominator is 6, and our numerator is 3 plus 4, 7 again. So we've got 7 and 7/6. But look closely. Can we simplify? We've got a top-heavy fraction over here. The 7's bigger than the 6. So this can be converted to a mixed number. How many 6's are there in 7? At least one whole. And how much is remaining? 6 is 1 less than 7, so I've got 1 remaining over the 6. That's 7 and 1 and 1/6, which makes 8 and 1/6. Just double check that that fraction can't be simplified anymore. 1 can only divide by 1, and if I divide both top and bottom by 1, I still have the fraction 1/6. So there we have it. It's fully simplified. Make sure you take a minute to copy that down. Notice how we had to convert to top-heavy here, but in the other cases, it's much easier if we don't convert to top-heavy. That's only for addition and subtraction. With multiplication and division, you must convert to top-heavy before you do the calculation. If you're ready, let's go on to some practice now. So go ahead, hit pause, and copy down all of these questions. Look at them carefully and check, do I need to convert to top-heavy before I perform the calculation? For questions 1 to 5, I hope you're automatically seeing this. I'm adding these mixed numbers. They will never end up with a negative fractional part, so I can go ahead and add them without converting to top-heavy. Whereas questions 6 to 10, I'm subtracting mixed numbers, so be careful. Get your common denominators and check if you can do that subtraction without getting a negative fraction part. If you can't, first convert to top-heavy, do your subtraction, and then make sure you simplify all of your answers. So go ahead and hit pause. Make sure you take your time to do that carefully and check over your answers, and then push play when you feel confident and you're ready to take it up. I hope you had a chance to hit pause, because these ones might take a little while. And here come your answers. For questions 1 to 5, as I said, they are adding, so we didn't need to convert any of these to top-heavy. First, we got our common denominators. Then we add our whole number parts and our fractional parts. Then, if any of our fractional parts need simplifying because they're top-heavy, or they can simply be divided both top and bottom by some common factor, we can go ahead and do that. For questions 6 to 10, remember we're subtracting. And I did want to check if you fully understood. So in all of these cases, we actually had to make them top-heavy. So I started with that step. Then I got my common denominators. Then I did my subtractions. And then I can see some of these need simplifying. Some of them are still top-heavy. And question 9 here is not top-heavy, but the numerator and denominator do have a common factor. And question 7 is no longer top-heavy. However, there is a common factor. 4 and 10 can both be divided by 2. So how did that go for you? Hopefully you found this lesson helpful, particularly the trick of knowing when you need to convert to top-heavy and when you don't. If you had any doubts or any concerns, please leave me a comment down in the comment section down below. Otherwise, well done, keep practicing, and I'll see you soon.